Let's take a look at performing integration by parts in the case of arctangent of t. Actually, we have a number in front, but we just carry that number. All right. Now, when we do integration by parts, I use a mnemonic rule to remember which function goes where. It's called LIPET. So this stands for logs. This is inverse trig, which is what I have. Polynomial exponential t. Now, because I comes first, that goes in the D column, but you're wondering what else is there? Well, that would be, I guess you can just say 1. And 1, you can think of it as a polynomial like a t to the power 0 or something. Okay, so arctangent will go into the D column. Of course, you do not want to put it in the I because the whole problem is to integrate it. Okay, we don't know what the integral is. Okay, so in the I column, since there's nothing left, I'm going to put 1. Now, if in case you're wondering, can you put 8 in the right-hand side? Yes, you can, but it doesn't really matter. So I'll just put it here. Okay, now, what is derivative of arctangent? Now, you guys are supposed to know this by heart, okay? You're supposed to know that derivative of arctangent is 1 over 1 plus t squared. By the way, a similar problem, you can see that on a test, is arcsine, and that one is similar, but you're going to have a square root on the bottom, and instead of a plus, you will have a minus, okay? Now, I don't need the arcsine, but just in case. Okay, so I'm just putting it there for your information. So this is what I get, and 8 I'm going to keep on the top. At the same time, integral of 1 is t. Remember, what do you have to take the derivative of to get 1? Well, t. Okay, so how does the tabular method works? The first thing you have to do is multiply diagonally across. So you're going to take this right here and multiply this way. And then you are supposed to integrate the box. Now, when you start with the polynomial, you eventually get to 0, and the box will actually become 0. But in this case, it's not. So what do I mean by the box? Well, the box is this particular row. Okay, so I'm just going to try to draw the box. Right? That whole thing you multiply and you integrate that. And unfortunately for this case, it is not going to be 0 because nothing is 0, so we do have to integrate. Okay, let's do that. So we multiply everything we see in the box and we'll get negative 8t over 1 plus t squared. The minus is still there. That minus there you have to keep. Okay, how do I integrate something like this? Well, here you have to use a u substitution. So you're going to say, okay, let u be 1 plus t squared. Then what is du? This is differential. Derivative of 1 is 0, but derivative of t squared is 2t. And then we also add that dt, because this dt right here will not disappear. That you have to have a relationship when you switch into u from t. What happens to dt? Well, you're going to divide both sides by 2t, and you're going to get that dt equals du divided by 2t. Okay, so let's perform the substitution. Negative. Okay, so I got 8t. For now, I'm going to just leave it there. Then 1 plus t squared, that is actually u. Okay, so that's just going to be u over here. And again, instead of dt, you don't just drop it. That's du divided by 2t. Now, notice something happening, which is a good thing that's supposed to happen. Your integral now only has u because the t's cancel out. So that's good. Now, what about 8 divided by 2? Well, that's 4. So we can actually pull this out. And we're going to wind up with 1 over u du. Now, hopefully you already know that that's just natural log of u. And you're supposed to put absolute value, but because in this case u is positive, t squared is non-negative. It can never be negative because you're squaring something. And then you also add 1, so that's going to be positive. So you can actually drop the absolute values. You don't need them. You can just use regular parentheses in this case. And then we substitute whatever u was back. And that's going to be our answer plus c. Okay, so we just integrated the box. And then we're going to add whatever we got for this integral to that diagonal multiplication, which is 8t arctangent of t. And then the box is -4 natural log of 1 plus t squared. Okay, so let me just submit this part to see if I got it. Okay, the last part is actually substituting the limits and see what happens. Now, here is what you should know about tangent. Some basic special angles that you should know. So here I'm going to put t, here I'm going to put arctangent of t. Okay, so what happens at 0, what happens at pi over 6, what happens at pi over 4, and pi over 3. We do not go to pi over 2 because at pi over 2 it's actually, tangent is not defined. Actually, I wanted to do tangent, not arctangent. Hold on. Yeah, okay, so it's just tangent. And then to get arctangent, you just switch the x and the y. Okay, so tangent of 0 is 0. Tangent of pi over 6. Here you just have to memorize. Unfortunately, there's nothing else. However, I'll show you in Desmos, you can actually, like, basically Desmos can remind you what it is. Tangent of pi over 4 is 1, and tangent of pi over 3 is square root of 3. Now, again, let's say I remember somewhat, I remember what they are, but I don't really remember. Okay, so if I open Desmos, make sure you switch to radians and say something like, okay, how about tangent of 0? It tells you that's 0. How about tangent of pi over 6? Well, that's definitely not 1, but what is it? If you remember, it has to be just one of those, either one over square root of 3 or square root of 3. Then you can just compute them and compare and match which one you get. And you can see that that's 1 over square root of 3. Now, pi over 4, that's easy. It's just going to tell you that's 1. And pi over 3 will be that's matching square root of 3. So if you want to do arctangent of 0 is 0. You just switch and kind of go back. Arctangent of 1 over square root of 3 is pi over 6. Arctangent of 1 is pi over 4, like that. Okay, and so on. So for me here, when I start substituting, I'm going to substitute 1, and arctangent of 1 is pi over 4. So this is going to be 8 times 1, which is just 1, right? Arctangent 1 is pi over 4. Okay, minus 4 natural log, and here we have 1 plus t squared. Well, 1 plus 1 is 2. Okay, what happens when you substitute 0? That's next. So we're substituting 0 into the antiderivative. Now, arctangent of 0 is 0, and then also t is 0. So that term will drop out. 4 natural log of 1 plus 0. Everyone needs to know that natural log of 1 is 0. If you do not remember that, just use Desmos, just put it in. I'm not sure what it is, but I can just do that and it'll tell you it's 0. So I don't have anything else other than 0 when I substituted 0. So this is really my answer. Can that be simplified? Well, a little bit. 8 over 4 is actually 2. So I think this is just going to be 2 pi. Let's put 2 pi and that's it.